Okay. Morning, everyone. Am I audible to you guys? Am I audible to you guys? Okay. Okay. Today we will mainly discuss about number theories or number theory systems. So these things you have already studied in your maths class before, either in discrete maths or any other school level maths. Okay. So it's more like I will ask questions and you guys have to answer me. Then there are certain theorems. It's mainly about primes. So those theories are mainly involved with your public key cryptography. All those mathematical things like modulus, arithmetic, primes and co-primes we have seen in case of RSA and Diffie-Hellman algorithms. Okay. Okay. So it's like so first you guys tell me what is prime numbers. Oh wait, let me share my screen. Divisible by itself, correct? Yes. Jimmy. Yeah. So both are correct. It's divisible by 1 and the number itself. Okay. Can you tell? So if I say prime numbers, your prime numbers will be 1, 3, 5, and so on. So can you tell me like what is, okay, I just write your numbers. Number itself, correct? So tell me what is relatively prime numbers, or you can say co-primes. Remember in RSA algorithm we discuss about co-primes. So tell me what is co-primes. Highest HCF of both the number will be 1. Yes, correct. HCF, or you can also say GCD, greatest common divisor. Okay, so for two numbers to become co-primes or relatively primes, then GCD of any number, suppose A and B, should be 1. It's HCF or GCD, same, it's just the greatest common divisor. Okay, it should be 1. So what can be the possible example of your co-primes? Can you give me example? There have to be like two numbers. Co-primes. There should be at least two numbers, or it can be more than two numbers. 6 and 10. Okay. So if you are saying 6 and 10, what are the factors for 6? 1. Are you sure? 6 and 10 is not co-primes. Yeah, 1 and 2. 2 cannot be 2. 2 cannot be a cofactor. Your highest common divisor should be 1. 10 and 15, you said. If I take 10 and 15, what will be the divisors? 1, 2, 5. And for 15, it can be 1, 3, again 5. No, this is not a coprime 2. Why? Because 5 is the another factors for both. So what's the GCD highest common divisor? 1 means what? There should not be any common divisors apart from 1. There should not be any cofactors apart from 1. 7 and 11. Okay. Yes, correct. For 7 it's 1 and 7 itself, and for 11 also 1 and 11. So you can say highest cofactors or divisors is just 1. 9 and 14, yes. 1, 3, okay, 1, 3, 9 itself. Then for 14, 1, 2, 7. Yeah, 9 and 14 is correct. Just remember the highest divisor of factor or common factor should be just 1, and 1 should be the highest common factors. Okay, so if two numbers satisfy this condition, then only it will be a relatively prime or co-primes. So this concept of co-primes we have also used in your RSA algorithm. You guys remember the steps where we find the co-primes. First, what we do, we just select two primes. Okay, see, one condition to be prime is that if both numbers are prime, then obviously those numbers will be co-primes. Correct? If both numbers are prime, like 7 and 11 both are prime, so obviously they will be relatively prime. But apart from this, there can be even numbers can be prime too. But you have to make sure that highest GCD will be 1. Okay, so if you take two prime number, obviously they will be co-primes. But yes, even numbers are possible too. But you have to make sure GCD should be 1 only. So in case of RSA, we always selected two prime numbers. Okay. Then after that, we find N. Okay. So remember the steps for RSA. First, we always select two primes P and Q. Then we find N which is known to everyone. And that N is mainly the product of P and Q. Right? After that, we find a torsion function, which was formula was p minus 1 q minus 1. Okay, I'll come to this torsion function later. This torsion function is also known as your Euler's function. Okay, so before going to the torsion function, let's see what is Fermat's theorem. Okay, there's another thing which is known as Fermat's theorem. Anyone heard about the Fermat theorem? Anyone know about Fermat theorem? It looks like I got the whole thing. Okay, you said no. Okay, so what is Fermat theorem? Or also you can say Fermat's theorem. If P is a prime number and A is any positive integer, which is not divided by P, or you can say GCD of your A and P is equal to 1. Okay. In that case, Fermat theorem or function will be a power p minus 1 is congruent to 1 mod of p. That means it will be 1. Anyone know what is congruent function? Congruent. This symbol is known as congruent. Anyone? No? Congruent means if I say A, P, it's a modulus function, right? I hope all of you guys know about the modulus arithmetic or modular arithmetic. So what happens in modular arithmetic? Tell me that first. If I say A mod P, what should be the answer here? A mod P. Yeah. Means what will be the equal sign? Is it like dividend or the remainder? Yes, 1. 6, yes. So it will be the remainder. Correct? So if it's A mod P, so you will always write the remainder of that thing. So if you say 10 mod 6, 6 into 1, 6, then it will be 4. Okay? So modular arithmetic, we mainly use, suppose there's a large number, and for the cryptography mainly, the problem is that we need to store bigger number as a key. Okay, so if we need to handle such a big number, it's a problem for both the parties. So in that case, most of the time they use modular arithmetic, especially for the public key cryptography, so that they can manage it very well. If they just use modular arithmetic, they will get a smaller value when they create a key. But at the same time, if opponent get the smaller key, then it will be difficult for them to get the bigger key. Okay. For the sender or the two parties, it's easier for them to handle bigger key, but in the time of decryption for the opponent, it will be difficult for them to guess the main big key. So most of the time they use modular arithmetic. They just take a bigger number, then they just use modular operations and find a smaller number of keys. Okay. So if I say 3 mod 2, what will be the answer? 1. If I say 5 mod 2, what will be the answer? 1. Correct? So now you can see for both cases 3 mod 2 is equal to 1 and 5 mod 2 is also equal to 1. In this case, here again I can say the divisor is 1. So sometimes we can say that 3 is congruent to 5 mod of 2. For both cases, we just get the same value. Okay. This is the congruent function. Okay. Just wait, I'm getting call from HOD. Okay. Okay. So your congruent function is what? From this example, what you can say, if two numbers have the same remainder, then we can say they are divided by n and they are congruent to each other. So I can say A congruent to B mod n. That means what? A and B have the same remainder when they are divided by n. Is it clear what is congruent? So two numbers will be congruent to each other when they will have the same number when divided by n. So there are other properties too, like this is one of the properties to be congruent. So second property can be like A equal to Kn plus P. So there can be a K for which that n plus B equal P E. It's another equation. If this condition is satisfied, then also it will be congruent to each other. Then again, the third conditions can be n is divisible by divides by both A minus B. Okay. So that's the basic condition. Congruent means both have same remainder in normal way. Okay. So in Fermat's case, what happens? This is if P is a prime number and A is a positive integer not divisible by D, or you can say GCD of AP equal to 1, then this is your Fermat's theorem. Okay, I just mixed up. This is Fermat's theorem, or this expression you can also write as A power P A equal to 1 mod p, correct? This expression I can write like this, and from this I can write what? A power p. I can take this a here, a mod p, correct? So for Fermat's theorem, one equation is this. The same equation you can just write, sorry, it's congruent, okay, in this form. A power p minus 1 congruent 1 mod p, or the same equation you can also write in a power p equal to a mod of p. That means this and this has the same remainder when we divide both the numbers by p. Okay? It's just all mathematical formulas. So if I say like 518 mod 19. Okay, this is your example, for example. Okay, so if you directly try to solve this equation, then it will be a problem, right? If you have to just find out what is the 5 power 18. Okay, then you have to divide the whole number by 19. Okay, so what you can do, you can just convert this expression into your Fermat's theorem. What is the theorem for this? It's a p minus 1, correct? So a p minus 1 mod p, we have to just convert it like this, and the same equation we can just write a p minus 1 1 mod p, correct? So here this equation, how we can write? 519 minus 1, correct, and mod 19. So this is nothing but your p minus 1. P is your 19. I can just write it 19 minus 1. So if I just divide this number, means put it in this format, the answer will be directly 1. Correct? Again, if I take just 519 mod 19, then again it will be, answer will be 19. If suppose mod 20, okay, in that case, if you take 520 mod 19, in this case you can see it's not like, we cannot put it in this format, correct? So what we have to do, what we can do for this case, I can write 519 into 1, then plus 1, right? Then mod 19. Okay, number is 518 mod 20. Then you have to make sure that you are saying this, right? 18 mod 20. In this case, it's not p minus 1. Okay, then you can, it's like p minus 2. So you can just make it like p minus 1 and minus 1. 20 minus 1 minus 1, correct? Sorry, here it's 20. Then you have to make it a plus. Somehow you have to make sure that it's come to this format. Okay? If P is 20 and you are saying it's 518, then you have to make sure this whole expression comes in terms of P. So you can just write 20 minus 1, 19, and minus 1, mod 20. Then you can again divide it, p 20 minus 1. So this modular function also fulfills your all those associativity rule and others rule. Okay. So now p becomes 20 minus 2. So in this case you will get again 1, and then you have to put it again in this portion. Okay, second line, then in the second line y will be v, line y we are using 20. Yeah, so it can be anything. If you can somehow put it in this format, the answer will be 1. Of course, every time it's not like this. So in this case, you can divide it like this. 20 minus 1, then minus 1. So you can just divide it. Mod 20 again, it will be a minus 1 mod 20 this side. Okay. Then for this portion, it will be 1. Then again, you have to solve this part. Okay. Then if you want to do that, which one example I gave for this portion, suppose what you can do, you can just write 519, then 5 power 1, then you can just write mod 19, correct? Then from here again you can write like 519, then mod 19, and you can just write 5 into mod 19, right? So from here this will be your what? This will come in this formula for this one A and this one A. So if both are same, the answer will be A. So for here, your answer will be 5. And again, for this portion, answer will be 5. And for this portion, again, you have to make it 1. Then it will be 5. Then again, it will be 25 mod 19. Again, now you have to keep doing the same thing unless the answer become less than your 19. Okay. For this portion, I got 5, and here it was 5 mod 19. So it was 5 into 5, 25 mod 19. Then again, you have to same process. You have to do the same process until you get the value which will be less than 19. Okay, I cannot just leave it like mod 19 here and keep 25, which is greater than 19. So again, you have to do the same thing. So in this case also it's same. For this case it will be 1. Then again you have to solve this part and do it once again. Okay. So this is the format theorem. So if you find anything which will be in this format, a power p minus 1 congruent to mod p, the answer will be 1. And a power p congruent to a mod p, then answer will be a. Okay. Next is your Euler's theorem. Euler's theorem, you guys know the normal one. Euler's theorem, I'm just giving you the theorem. Okay. The theorem is if there's two numbers like a and n, so you can just say for every a and n that are relatively prime, or you can also say co-primes, then a phi of n is equal to, not it's congruent to, it's 1 mod n. Okay, this is your Euler's theorem. This phi function is nothing but your torsion function. There is a proof too, but proof is not that important at this level. Means, of course, you are welcome to see how you can just prove the theorem. Not a problem. Otherwise, Euler's torsion function is just, what is this torsion function? It's just how many numbers are there between 1 to n minus 1. You can also say this torsion function is nothing but how many numbers are there between 1 and n minus 1, and they are relatively prime to n. So this is the function, torsion function we use in case of RSA algorithm. Right? So this equation we can also write like phi n equal to n minus 1. Okay, remember this is just a case, one type of case. Then again you can write n equal to pn into q, where p and q are two primes. This is the function we use in case of our RSA function. Remember, we use p and q, then find a product, then we find this value. So this equation we can just write, or I can just say like phi of n, or phi of p into q. This is nothing but phi p and phi q. This term you can just write p minus 1 and q minus 1. And I showed with example how this equation becomes p minus 1 and q minus 1 in the last class. So this is all about number theorem. These are just some of the concepts we used in RSA and Diffie-Hellman chains. Like in public cryptography, everything is about modular arithmetic and this torsion function. Okay. If you want to see the proof, you can just go ahead and find the proof for Euler's theorem. Format function, just remember, if anything is in this format, you can just directly write the answers like equal to 1 and equal to a. Yeah, if it's directly in the format, you will get the answer. If it's not in that format, you have to do some more calculations. But if it's 20, you have to just divide it plus. If your mod is 20, then again the term you have to convert it into some of the expression which will help you just put everything in this format. Okay. Okay, that's all for today. These are the basic maths, I guess. Ma'am, show the slide for congruent properties. Okay, wait. Congruent property. There is no slide actually. This is for the congruent. The mean is, it will be, remainder will be same if they are divided by n. Again, there can be a k for which kn plus b can be equal to a, and your n can be divided by a minus b. Okay. Okay. Okay, that's all for today. Thank you. Okay, attendance done. Thank you.